Hello everyone and welcome to the presentation on HVDC GIS prototype installation. With the presentation I'll try to answer the question, how does the prototype installation increase the technology readiness level of HVDC GIS? My name is Michael Gatzsche. I have a background in electrical engineering, and since 2017 I've been working with ABB and now Hitachi ABB power grids in the R&D of high voltage gas insulated switchgear. I'm member of the promotion work package 15, where I've worked with the prototype installation test and pre-standardization activities in the work package. In the presentation, I want to speak about the role of the prototype installation test, the specification and rating of the HVDC GIS, the prototype installation itself, and finally share some results. What's the role of the prototype installation and the prototype installation test in the total product life cycle? When we have a new technology or a new product like HVDC GIS, when we as a manufacturer start with the R&D process, including simulations and development tests, the final goal of these efforts is to have a product that can be used in the field and that operates reliably for several decades. And to get there, classically, the R&D process finishes by performing all the type tests and completing them successfully. At least that's how we do it for an established technology like AC GIS. However, since HVDC GIS is a new technology, it's a bit more difficult. It starts with the type tests, as you heard from Nadu. They are a bit more complicated, and as of now, they're not even a fixed standardization. However, there are a lot of pre-standardization activities going on, and there are recommendations on testing, for example, from SIGRE, that recommend to include an insulation system test that combines dielectric and thermal stresses, that includes superimposed impulse voltage, and of course that includes all the other AC GIS tests like temperature rise or short time withstand current. Because HVDC GIS is a new technology, even a completion of all these type tests would only put the technology readiness level of 6 out of 9, because as of yet we only have very limited operational experience with HVDC GIS. And to bridge this gap to the real in-service operation of the HVDC GIS, the prototype installation test is proposed. It is a full-scale demonstration, including specification and engineering of an HVDC GIS installation, the installation and commissioning of a quite large test pole, on-site long-term testing for more than a year with representative stresses, dielectric, thermal, mechanical. We have monitoring and diagnostic systems included in the test pole and third-party examination of all the steps. And a successful prototype installation test would verify the overall performance of a manufacturer to develop and produce and commission an HVDC GIS product. It is not a mandatory test, and it is also not a combination of all the type tests. And a successful prototype installation test would put the technology readiness level at 8 out of 9. So basically it would make it ready to be put in service. How can we specify an HVDC GIS? In promotion, we have done this, for example, with this case study where we have an HVDC link between Scotland and Shetland, and on this HVDC link we would add some offshore wind park. And to connect this offshore wind park, we could have a 3-terminal HVDC hub offshore, and there we would need a 320 kV HVDC GIS to reduce the size of the platform. And the proposal for the test pool was to use a GIS with the ratings you see on the right-hand table, and these ratings would fulfill the requirements for such a project. If we have a rated voltage of 350 kV, we have a superimposed lightning impulse voltage of 1050 kV, switching impulse of 950 kV, and 4000 amps rated current. The test pool itself looks like this. This is a rather large GIS ring with two SF62R bushings. These bushings are used to connect the high voltage from the test lab with the test pool itself. We have a second bushing to do some extended tests where we test the voltage withstand of an open disconnector gap. And the test pool has the form of a ring to be able to induce a heating current using conventional current transformers, so that we can also have thermal stress and the influence of the high temperatures on the dielectrics as part of the test. The prototype installation consists of all major components needed for such an HVDC hub. We have different gas compartments, we have all kind of modules, we have L, X, T-shaped modules, we have dismantling units, there are partition and support insulators, as well as disconnector insulating rods included as solid insulation, and we have DC capable instrument transformers, and we have the switching devices, the disconnector earthing switches and the fast-acting earthing switch included. We have also monitoring systems for gas density. PD, we have an established UHF system, as well as more experimental optical, high-frequency current transformer and magnetic antenna systems. We have the arc detection and enclosure temperature monitoring systems. In this time-lapse video, you can see the installation of the prototype installation test pool. We start by assembling the factory modules on their steel supports in the form of the basic ring. You can see that all the modules are connected, the cleanliness care is taken. Then we attach the bushings, configure the secondary technology, and then we actually start with the AC commissioning test that's now connected. The high voltage test passes, and after that the test pool is ready for the prototype installation test itself. And of course, you've learned all about the prototype installation test itself from Nadu's presentation. So here I just want to give a very short summary of the results. We have done the prototype installation. This means we have installed a pole consisting of type tests of modules of a type tested HVDC GIS design. All major components of this HVDC GIS were included. It has a realistic size. The project execution was done like a customer project with specification and engineering, factory production, including routine test, on-site installation, on-site commissioning by the manufacturer team. And then the prototype installation test was executed according to specifications of SIGRE and promotion. There was third-party inspection of all steps, and in June of this year, the test was successfully finished. And with the successful completion of this prototype installation test, we have now increased the technology readiness level of HVDC GIS from 6 to 8. So thanks a lot for listening to this presentation, and of course I encourage you to join the Q&A session if you have follow-up questions on this. Thanks a lot.